Hi, my name is Ingrid Delbard, and I'm a planetary scientist at Brown University. I work on the InSight mission studying impact craters on Mars. This week, we're learning about how InSight works with other missions to Mars to deepen our understanding of the red planet. The Mars Reconnaissance Orbiter has a super high resolution camera called HiRISE that flies over Mars and takes pictures of the surface in extraordinary detail. The first quiz is about Cerberus fossae. This is a region with very fresh, young-looking cracks in the crust. It's an area that might be seismically active, so InSight is listening for signals of marsquakes coming from that area. Hopefully you're able to take a look at the map of Mars and find Cerberus fossae here in Zone 2. In high-res images of that area, you can see how steep the walls of these long pits are. High-res images show boulders that have fallen from the walls down to the floors, maybe even because of a marsquake. These pits or fossae are several hundred kilometers long, or answer number 2. Quiz 18 is about the Tharsis volcanoes, which are huge volcanic mountains on Mars. InSight's heat probe will tell us more about how volcanoes like this formed and how they're involved in the thermal and tectonic history of the planet. The tallest of these planets is Olympus Mons, which is the largest volcano in the whole solar system. After that, they're ranked by height from highest to lowest: Ascraeus Mons, Arsia Mons, and then Pavonis Mons. This is answer number 3 on the quiz. Even though Pavonis Mons is the lowest of these 4 volcanoes, it's still 14 kilometers high, which is almost twice as tall as Mount Everest. Both Olympus Mons and Mauna Kea, the largest mountain on the Earth, have similar gentle slopes of around 8 to 10%. Answer number 2. This is because both of them are shield volcanoes, which form from many eruptions of very fluid lava that flows outward very easily, building up a broad hill over time. The type of rock that makes up volcanoes like this is called basalt. Answer number 2. Quiz 19 is about the sizes and shapes of small craters on Mars. The HiRISE camera is so powerful that it can image even very small craters, some as small as cars. In the aerial photo, you can see that the resolution of the HiRISE camera at Mars is like that of a satellite image of Earth. It can resolve things even smaller than city streets, which are about 20 meters in diameter. Answer number 3. An example of something that size on Mars is crater number 3, shown here, which is also about 20 meters in diameter. Answer number 4. Crater number 2 in this image has an interesting shape. It looks like several overlapping craters. This could actually be due to a number of different things. It's possible that a meteoroid broke up in Mars's atmosphere and the pieces formed several craters simultaneously. Answer number 1. However, that's less likely for an impact of this size. Another possibility is that several craters formed on top of each other over time. Answer number 2. Although it's quite a coincidence that they all fell in the same spot. The shadows on the craters are also useful. They're caused by the sun's light illuminating the surface of Mars. Where part of the surface sticks up and blocks the light, it causes a shadow. Because we see shadows, there must be light, so this photo was not taken at night on Mars. The length of the shadows depends on how high the object blocking the sun is, so shadows can be used to estimate the depth of these craters. InSight has a really great weather station on it too. It can measure pressure and wind speed and direction. These are important for understanding how wind-formed features form and evolve, such as sand dunes. This HiRISE digital terrain model measures the heights of these Barken dunes, which are crescent-shaped dunes commonly found on the Earth and Mars. They are on average 20 meters high and 190 meters long, which is answer number 1 on the quiz. Barken dunes are extended along the direction of the wind, with the horns of the Barken dune shape pointing downwind. So here you can tell the winds tended to blow roughly from east to west at the time when these dunes formed. We spent years picking the perfect landing site for InSight on Mars. Every mission has to consider this carefully so spacecraft can land safely. We're lucky we can use HiRISE images and other orbital data to study different spots to land and choose the very best one. InSight landed at 4.5 degrees north latitude, 135.6 degrees east longitude. This is actually fairly close to the location of the Curiosity rover, which landed to the south at 4.6 degrees south latitude, 137.4 degrees east longitude. This system of latitude and longitude has to be based on a 0 longitude somewhere on the planet. A specific crater was chosen to represent 0 longitude on our maps of Mars. This is crater number 2 on the map you saw. At that landing site, HiRISE took this image of InSight on the ground soon after landing. The lander itself is in position 2, with a dark blast zone around it where the retrorockets of the spacecraft blew away light-colored dust. You can even see the parachute after it collapsed on the ground in position 3 in this image. That's it for this week. Congratulations on participating in this week's InSight at Home. Stay safe and stay curious. That's it for this week. Congratulations on participating in this week's InSight at Home. Stay safe and stay curious.